Hi friends, welcome to my channel AI Basics with AK. Here we are with another new episode in our season 3 Introduction to Statistics, episode 11 Type 1 and Type 2 errors, and we will also introduce a one sample tests. So let's recap what we have discussed in our episode 10, which is we have introduced a topic called hypothesis testing. We have introduced that there is whenever we want to test our hypothesis, we assume a null hypothesis, which is nothing needs to be decided, like it's like a decision. So we consider a null hypothesis as a default, as is status quo, and an alternative hypothesis, which means we will take a decision considering the hypothesis that we are going to test it out, for which we use a probability value, and then there is an default threshold. Usually it is 0.05, and whenever the probability is less than 0.05, we take a decision based on our claim that we have introduced in our alternative hypothesis. Now, say for example, there is a chance that our decision might be wrong or right. Isn't it so? It's not always that whenever we take a decision considering the data, there is also a chance that we can be wrong. So that's what we will learn about two types of errors, which is a type 1 and a type 2 error. So when we reject or fail to reject a null hypothesis, we are taking a decision under uncertainty. We all know that we always wants to take a decision under uncertainty, and statistics especially helps us to reduce the uncertainty by considering whatever we have learned in our previous episodes. However, have we ever seen a full truth? No, we have never seen a full truth. We only saw sample. So samples can always mislead us based on the sample we have collected. Maybe the data is not sufficient. Maybe we have collected the wrong sample. It can be anything. So there are two different types of errors, famously we call as a type 1 and a type 2 error. We are rejecting a null hypothesis. It means we are actually claiming that whatever we have hypothesized is true. Then what we are trying to do here, we are trying to create a false alarm. It means a person is not guilty, but we have announced a verdict as guilty. It's a false alarm. It's an judgmental crime. It can be in few cases, right? What is a type 2 error? We are failing to reject H naught when it is actually false. It means we did not reject the null hypothesis, and we have not proven a person as a guilty. It means we have missed a signal and beautiful opportunity to prove somebody a person is a guilty, carrying forward the previous example of innocent and guilty kind of a thing. So both cost us very differently, and we need to consider the cost. But however, we will learn about cost benefit analysis maybe in the future seasons. So this is a famous error matrix where you can see here we reject null hypothesis and fail to reject null hypothesis when actually H naught is true and H1 is false. If we reject null hypothesis, means we are agreeing with alternative hypothesis. So this is a true positives. It means we have correctly identified this is a true positives. And we fail to reject null hypothesis, and then the alternative hypothesis also we have rejected, not rejected. We state, we fail to reject the null hypothesis. So this is also a correct kind of a thing. But as we discussed in our previous slide, there is a chance that we reject null hypothesis, but actually the null hypothesis is true, which is called a type 1 error, which is called an alpha usually, and the type 2 error is called as an beta. So type 1 error, to put it simple, is nothing but we are raising false alarms. And type 2 error is that we have missed the chance ideally. Depending upon the case, okay, we there is a cost for either raising a false alarms or there is a cost for missing a chance. Let me discuss about couple of examples at this point of time. So here, type 1 kind of a thing. Here you can see that a drug actually does nothing, but your test says it works. So patient receives an ineffective drug. So the drug doesn't, it's like a placebo, right? And say for example, machine is fine, but test flags it as faulty. So the production was shut down unnecessarily. This is another example. What will happen? Acting on something that isn't real. Okay, this is a huge problem whenever if we are, our cost of acting is actually a higher. If there is a thing like if you want to act, there is a cost for every action. Okay, then this is a problem. Now there is an alternative kind of a thing. Okay, say for example drug work and then your test misses it. Say beneficial treatment is never approved. It means if there is a powerful cancer drug and maybe our test did not approve it, then what is happens, the patients are not receiving that cancer drug. It's very sad, right? That is a very bad, sad thing. And similarly, a machine is broken, but our test says, okay, it's perfectly fine. It's a missed signal. What happens? There is a chance that, okay, there are defective products that might reach to the customer and it might lead to our huge loss when customer can raise some complaints about that. Say for example, the weight of each of maybe each product has to be, say if it is a liquid, maybe it has to be approximately 1000 grams. Because of the defective product, maybe it is giving maybe 970 grams for each and every pouch or something. What will happen if consumer sees this difference? Then he will say that the company is legitimately doing this fraud, so we have to find that company, and there is every chance that court or the government can sue us for this fraud, even though there is no fraud, but it is actually we have missed a signal. So there is a cost for everything. You are here, okay, we are acting for false alarms. Here we are not acting when we have to act, because and there is a cost for not acting because somebody will act. Like here the consumers can act and file a court case and then the court can sue us. So there is a cost for both of them. This is very important for us to understand and comprehend whenever we actually tackle any machine learning problem. What is which type of error we have to reduce? Either we have to reduce false alarms or we have to be sure that there are fewer missed signals. So this is very critical, and we will see further in our machine learning class how we will each type of accuracy, how we can optimize our machine learning or choose a specific model based on our criteria. So let's understand, okay, the trade-off between alpha and beta, maybe the trade-off between lowering alpha and raising alpha kind of a thing. So whenever we lower alpha, there is for sure that there will be fewer false alarms, because we are tightening, we are giving very less chance to prove something that our hypothesis can be true. So it becomes very harder to reject null hypothesis. What happens in this case? Yes, there will be case where there will be more missed signals. When do we need to use it? Whenever our false alarms are very costly, we need to we will be trying to use this lowering our alpha level. It means we are making it difficult for us to prove that our hypothesis is true. Similarly, whenever we raise it, whenever we want, it is easier to reject. It means we are giving a little bit easier chance to reject null hypothesis. Why? Because whenever the missing a real effect is very costly for us, we will be using it. So there will be, of course, there will be fewer missed signals, but there will be more false alarms, right? It means we will be telling something is true, but actually it is not true, kind of a thing. So when it is helpful, especially helpful for example like cancer screening or something, which is very vigilant kind of a thing for an both a patient as well as an doctor kind of a thing. Okay, now let's, so in generally there are two types of test. One is a one sample test and a two sample test. In this episode we will learn about one sample test. In the next episode we will learn about two sample test. What is a one sample test? It means that there is a known or a claimed thing which is an default value kind of thing. Say for example, there is a known claim that, okay, in our previous example, that say for example, the pouch weight by default is 1000 grams whenever the machine fills the liquid. So this is a default claim. We call this as a null hypothesis. And then we collect a sample and we want to claim it that maybe alternative hypothesis is that, okay, the default pouch, okay, is less than 1000 grams. Now that's a one sample test. It means we know that, okay, there is a known or a claimed value, which is this. There is a known and a claimed value, and then we are collecting a sample, which is only one sample, to test whether this known or claimed value is true or not. So for that we use, okay, in generally two types of tests, which is a z-test and a t-test. When our population standard deviation is known, which is not famously known, so then we usually use g-test. When population standard deviation is unknown, which is actually in most of the cases, we use t-test. So in practice, sigma is never known, so t-test is what you will use most of the time, which is what I was saying in the previous episodes as well. So this is just a quick guide for you. When sigma is known, okay, then z-test. Sigma is unknown, t-test. Whenever it is larger the sample and sigma is unknown, t-test, because z becomes t whenever there is larger samples anyway. So it's always safer to use t-test. And in n is small and sigma is unknown, t-test, because it caters for your fatter curves, the thicker curves kind of a thing, even for t-test, which we have seen for lesser degrees of freedom that we always seen it in our previous episode. So whenever we are not sure, so default always to t-test. So the t-test was invented specifically because we rarely know sigma in practice. It is the workhouse of one sample testing. So that's it. And then in next episode, we will see about two sample tests, and then we will have a short quick demo on how to conduct both a one sample test and a two sample test using Python in a very few lines of code. That's it for today's episode, and we'll catch up in the next episode. But before winding up these episodes, let's see the homework that you can complete such that it will improve your understanding in a better way. There are a couple of questions that I have kept it out. In the first question, say for what I have set is that we have set an alpha as 0.01 instead of 0.05 for a medical study. And how does this affect a type 1 and a type 2 error and a power? Power is nothing but 1 minus alpha, and explains the trade-off in plain language. Just based on understanding, very simply, okay, whenever we lower the alpha, what will happen? What we are trying to ensure? Are we trying to ensure that type 1 error is reduced or type 2 error is reduced? What will happen? We already discussed in length. I think you can answer this in a better way. The question 2 is that it's just more about, for your understanding, it's not required to do it, but if you can do it, you want to do it using programmatically, it's a better thing. Simulate 501 sample t-tests where H0 is actually true. What fraction of tests falsely reject H naught at alpha 05? What does this confirm about type 1 error? So what I was trying to tell here is that simulate one sample t-test where actually H naught is true and try to see in how many cases actually we get a type 1 error. This helps you in understanding about probability and how we actually ensure that we weigh the costs of our predictions always. This just lays the foundation whenever we are trying to predict something, any fancy prediction that we do it whenever we learn machine learning kind of a thing. That's it for today's episode, and we will learn about two sample tests in the next episode. See you in the next episode. Thanks a lot.